Okay, we're continuing with more integrals of rational functions, where in order to integrate a rational expression, a rational function, we perform partial fraction decomposition to break up the rational function into simpler rational functions, sums of simpler rational functions that we can integrate. Okay, so here we have a rational function, 1 over t squared minus 1 squared. And so the first step is, when it comes to partial fraction decomposition, is so you check to see that it is the order of the numerator less than the order of the denominator. And so this is a polynomial in the numerator. 1 is a polynomial by definition. And so the order of this polynomial is 0. The order of this polynomial is 4. And so it is. And so the order of the numerator is less than the order of the denominator. Okay, so we don't have to do polynomial long division. And the next step is to factor the denominator. And so with any, we've talked about how with any polynomial, no matter what it is, any polynomial can be factored into to where you're strictly left with products of quadratic factors and linear factors. And so that's where you want to fully factor the denominator to where it can't be simplified or factored anymore. Now here we do have this is a quadratic factor squared. So when the denominator will be factored to linear and quadratic factors, and those factors could be to the 1 power or to any positive integer power. And so here we have a quadratic factor to the power 2. So, you could kind of think, well, this is already in this. We have a quadratic factor, and that's all we're left with. So maybe this is fully factored. And really, you want to go, if you have a quadratic factor, you want to if you can go turn that into linear factors, then you want to do that. I mean, linear factors are simpler than quadratic factors. Okay, and so this is a quadratic factor is ax squared plus, let me put t, a t squared plus bt plus c. So this is a quadratic factor with b equal to 0, c equal to minus 1, and a equal to 1. Now you can check to see if the quadratic factor can be factored anymore using the discriminant. So from the quadratic formula, you do, it was I just had the formula out there, but you do b squared minus 4ac. So we have b squared, b is 0, minus 4 times a times c. So this is 0 minus 4, so positive 4. If the discriminant is greater than or equal to 0, then you can factor it. And so we want to go ahead and do that. So what we're going to say is we've got t squared minus 1 is t plus 1, t minus 1. Okay, but what we want to do is we can, based on properties of exponentials, we can write this as right. So now we've got two linear factors squared. And so now this is fully factored. I mean, we could have done the partial fraction decomposition with this quadratic factor, but the result wouldn't have been as simplified as this is going to be. So, okay, now this is fully factored. And so now the next step is we want to write the form of the decomposition. And so we do this for each factor. So we'll start with the t plus 1 squared. So when you got a linear factor to a power other than 1, what you do is, so we're going to put the linear factor to the first power to a constant plus the linear factor to the second power with another constant in the numerator. Okay, so now we're done with that first factor, and now we're going to do the same thing for the other factor. Okay. And there we go. That's the form of the decomposition. So now we want to multiply this entire equation by the least common denominator to clear the fractions. So this is going to be t plus 1 squared times, and then t minus 1 squared. So we've got 1 is equal to a times, so t plus 1, t minus 1 squared, plus b, and then t minus 1 squared, plus c, t plus 1 squared, t minus 1, plus d times t plus 1 squared. Okay. And so now what I would do is, this can get pretty complicated, but, and so I would, let's go ahead and plug in values of t and whatever, and see if we can quickly get some constants. And if it gets too complicated, then we'll go the other route and group terms together. So, okay, if t is equal to 1, then we can get d, because we've got all of these go away, and we're left with 1 plus 1 squared for d. So d is equal to 1/4. Okay, is there another simple substitution we can make for t? We could do t is equal to minus 1. In that case, we've got 1 is equal to, all of these go away, and we're left with, so minus 1 minus 1 is minus 2. So for b is also equal to 1/4. Okay, so let's put this over here. We've got b is equal to 1/4. D is equal to 1/4. So let's simplify this a little bit. So we've got a, we'll need to, all right, so t minus 1 squared is t squared minus 2t plus 1 plus, 1/4 t squared minus 2t plus 1 plus c t squared plus 2t plus 1 plus d. Actually, okay, let's not, this is going to take too long. I think it's going to be easier if we, it'll be easier this way. It'd be easier if we say, okay, let's make t equal to 0. Okay, so 1 is equal to, you have 1 times minus 1 squared is just 1, so we would just have a. Yeah, this could be a lot faster. Okay, a, and then plus 1/4 times minus 1 squared plus, okay, you've got 1 squared times and then minus 1, so it's going to be minus c. Okay, and then plus 1/4, and then this is 0. Yeah, there we go. So we've got a minus c plus 1/4 plus 1/4. Okay, now 1 minus 1/2 is 1/2. So now multiplying this entire equation by 2, you have 2a minus 2c is equal to 1. Okay, so now let's make t equal to 2. All right, so we've got 2 plus 1 is 3, 2 minus 1 is 1. So 3a plus 1/4 times, okay, 2 minus 1, so that's just 1/4, plus c times, okay, 2 plus 1 is 3, 3 squared is 9, 2 minus 1 is 1, okay, plus d, okay, t plus 1, so times 9. So 3a plus 1/4 plus 9c plus 9/4 is equal to 1. Okay, 3a plus 9c plus 10/4 is equal to 1. What is 10/4? That's 5/2. Okay, 1 minus 5/2. So 2 over 2 minus 5/2 is minus 3/2. Multiply this by entire equation by 2. You've got 6a plus 18c is equal to minus 3. So 6a plus 18c is equal to minus 3. Okay, so if you multiply this equation by 3, this first equation, you have 6a minus 6c is equal to 3, and then 6a plus 18c is equal to minus 3. Subtract these two equations. You have minus 6c minus 18c is minus 24c, and then 3 plus 3 is 6. So c is equal to minus 6 divided by 24 minus 3. So minus 1/4. Okay, so 2a minus 2 times minus 1/4 is equal to 1. 2a plus 1/2 is equal to 1. 2a is equal to 1/2. A is equal to 1/4. So A is equal to 1/4. C is equal to minus 1/4. Okay, so we've got, okay, A is 1/4, B is 1/4, C minus 1/4, D 1/4. Okay, so this integral is equal to, and we could these separate integrals. So 1/4 Okay, now when it comes to any kind of linear, so again, there's, when it comes to these pieces these forms that we break up any rational function into, anything that involves a linear factor, so it would be the linear factor to the first, second, third, whatever power, those you can integrate any one of those. Well, if you could do it in your head, if it's simple enough to do it in your head, go ahead and do it. But if it's not simple enough to do in your head, you could always use a U substitution. It'll work for any one of these. You're always going to have a constant you can take out, so you'll have a 1 in the numerator, and then in the denominator you're going to have a linear factor to some power n, where n is 1, 2, 3, whatever. Say U is equal to the ax plus b, and that will work. As that substitution will work. Okay, so we can do some of these in our head. Okay, now this one we should be able to do in our head. This is pretty easy. So the natural log of, or no, this would be, okay, so we should have, okay, yeah, 1 over, the derivative of 1 over t plus 1 Okay, let me just do the u substitution. So u is equal to t plus 1. du is equal to dt. So we've got 1 over u squared du. Okay, so minus 2 plus 1 is minus 1. U to the minus 1 over minus 1, which is minus 1 over u. So minus 1 over t plus 1. Okay. Okay, so minus 1/4. Okay. And then here we've got and then this is going to be minus 1/4. Okay, we can write it like this. There we go. Okay, so we want to do partial fraction decomposition here. We see that the degree of the numerator is less than the degree of the denominator. And so the next step would be to factor the denominator, but it looks like it's already factored. We have a linear factor and a quadratic factor. So, okay, we go one factor at a time. So the linear factor to the first power. Okay, now the quadratic factor to the first power is just you put the quadratic factor and that's it. Okay, now let's solve for a, b, and c. Let's clear the fractions, multiply by the least common denominator. So we've got okay. So we've got ax squared plus 9a plus bx squared minus bx plus cx minus c. We've got okay plus and then c minus b plus like that. Okay, so there's no x squared, so we have a plus b is equal to 0, a is equal to minus b. There's no x term, so we have c is equal to b, and then we have 9a minus c is equal to 10. Okay, a is equal to minus b. But b is equal to c. Minus 9c minus c is minus 10c. So c is equal to minus 1. Therefore, b is equal to minus 1, and therefore a is equal to 1. Okay, so we've got okay 1, and then I can put a minus out here and then make this x plus 1. Okay, so we've got, and then Okay, so how do we integrate this? Well, when we went through the textbook, this is what one of the main things we talked about in this section. You know, because for any partial fraction decomposition, the any of these terms here are going to be one of four types. It's going to be linear denominators with a constant in the top raised to the first power, or linear factor denominators with a raised to any other positive integer other than 1 with a constant in the top, or you have a quadratic factor just like this, where, with ax plus b in the numerator, where a or b could be 1 or, any numbers, and then the quadratic factor raised to the 1 power in any power. So here we've got a quadratic raised to the first power. Okay, and so we talked about, in general, for any quadratic in the denominator raised to any power with some kind of ax plus b in the numerator, the way we solve this is we're doing we separate it into two separate integrals. Okay, and this first integral with the x in the top, we can use a u substitution. Okay, so we've got 1/2 u. So this is 1/2 natural log of the absolute value of u, which is, okay, so okay, now this, they give us a formula for this in the textbook. Here's the formula. So this integral is where a is 3, so 1/3 arctangent x over 3. Okay, so 1/3 arctangent x over 3. And there we go. So this here is natural log of the absolute value of x minus 1. Okay, minus, and then so we'll have the minus 1/2 natural log, and then minus 1/3 plus c. And that's it. That is the integral. Okay, so we've got a rational function here. The order of the numerator is less than the order of the denominator, so we want to do partial fractions on this. And so the first step is going to be to factor the denominator. Okay, so, we went over factoring in full detail earlier in this playlist. And so when you've got four terms like this, you could consider grouping. So let's say that we've got, if we've got the x cubed plus x squared plus 1. If we factor out an x here, we've got x squared plus 1 plus x squared plus 1. There we go. So we can factor out an x squared plus 1, and then we've got x. There we go. Okay. So x squared plus 1. Okay, and that is fully factored. Right? We've got a quadratic factor and a linear factor. We can't go any further. So we could start, let's start with the linear factor to the first power. So x plus 1 Okay, now the quadratic power factor to the first power, bx. There we go. So now let's solve for a, b, and c. Let's multiply by the least common denominator to clear the fractions. So okay, so when x is equal to -1, you've got -4. This goes away, and you've got 2a. So a is equal to -2. Okay, so now we've got 4x is equal to -2x squared minus 2 plus bx squared plus bx plus cx plus c. 4x is equal to, we've got b minus 2x squared plus b plus c x plus c minus 2. Okay, b minus 2 is equal to 0, so b is equal to 2. C minus 2 is equal to 0, so c is equal to 2. Okay, so a is equal to -2, and then bx plus c is 2x plus 2. Okay, so we've got the integral of -2. Okay, and then we can take out a 2 here, and you've got okay, so this is -2 natural log of the absolute value of x plus 1 plus 2 plus 2. Okay, so here, if u is equal to 2x, no, u is equal to x squared plus 1, then du is equal to 2x dx. 1/2 du is equal to x dx. So we've got the integral u, and then we take out the 1/2. So natural log of the absolute value of x squared plus 1. Okay. Okay, and now this integral is going to be 2 times, so we got 1 over x squared plus 1 squared. So 2 times 1 over a is just going to be 2 arctangent x. Plus c. Then there we go. And actually, if we can simplify this a little bit more, because x squared plus 1 is always positive, right? So we don't need the absolute value. And there we go. Okay. So the order of the numerator is less than the order of the denominator. So let's do the partial fraction decomposition. Okay, so we need to factor the denominator. So if we say that u is equal to x squared, therefore u squared is equal to x to the 4th. So we've got u squared plus 5u plus 4 so x squared plus 4 times x squared plus 1. So we don't the denominator we don't worry about. Okay, and that's fully factored. We've got two quadratic factors. We can't factor these anymore. So let the first quadratic factor, they're both raised to the first power. So x squared plus 4, then ax plus b. We're done with that factor. Then x squared plus 1, cx plus d. Now we need to solve for a, b, c, and d. Multiply by the least common denominator. Okay, so we've got okay, it looks like there's no simple substitution we can make for x and find a constant. So let's just go ahead and distribute this. So ax cubed plus ax plus bx squared plus b plus cx cubed plus 4cx plus dx squared plus 4d. Okay. So we've got a plus c x cubed plus b plus d x squared plus a plus 4c x plus b plus 4d. Okay, so the x squared, so b plus d is equal to 0, so b is equal to minus d. Okay, we've got a plus c is equal to 1. We've got a plus 4c is equal to 4, so let's do that. A plus 4c is equal to 4. We can subtract these two equations, so 1 minus 4 minus 3c, and then 1 minus 4 minus 3, so c is equal to 1, and therefore a is equal to 0. Okay, we have b plus 4d is equal to 3. B is minus d. So 3d is equal to 3d is equal to 1. All right. So ax plus b. Yeah, and then that means that b is equal to minus 1. So ax plus b, we've got minus 1. And then cx plus d, it's going to be x plus 1. Okay. So we've got minus, and then, okay, plus, and then we can go ahead and separate this, x squared plus 1 plus, okay, so this u is equal to x squared plus 1, du is equal to 2x dx, 1/2 du is equal to x dx, So we've got 1 over u du with the 1/2 out front. So, okay. Now here we've got 1 over 2 arctangent of x over 2 with the minus sign up front. Okay, here we've got, it's going to be arctangent x. And there we go. Oh, we can, this is going to be always positive. So we can remove the absolute value. That's the integral. Okay, so if we take a look here, we see that the order of the numerator is less than the order of the denominator. And so normally we would go ahead and perform partial fraction decomposition, but if we take a look, so all we have in the denominator is a single quadratic factor, right? A quadratic factor is ax squared plus bx plus c. So this is a single quadratic factor raised to the first power. Now, we would potentially factor this, but we can check to see if this can be factored using the discriminant. So b squared minus 4ac, b squared minus 4 times a times c. So the discriminant is negative, which tells us that this can't be factored any further. So this is already as broken down as it can get. We can't do partial fraction decomposition anymore. Okay, so but as I've mentioned, once you have any rational function that's been fully broken down by partial fraction decomposition, then it's going to be in one of 4 forms. And we talked about how to integrate all 4 of those forms. So what is this? Well, up to this point, we've been integrating rational functions with quadratic factors, but they've all been in this form of like an x squared plus or minus a squared. And this is what when it comes to integrating quadratics, all of the methods that we learned are based on this form of a quadratic. So what we're going to do in this situation is we're going to use completing the square to put the quadratic into a form like this. Okay, so let's do completing the square. So x squared plus 2x plus, okay, x plus a squared is x squared plus 2ax plus a squared. So in this case, 2a is equal to 1. Or no, 2a is equal to 2. A is equal to 1. 1 squared is 1. Now put a minus 1 to not change the equation. So we've got x plus 1 squared plus 4. X plus 1 squared plus 4. Okay. Okay. So now what we want to do is separate this into 2 separate integrals. Okay, now, but we want to get this x plus 1 squared here. We want to get that into the form of just like a single variable squared. So we're going to say for both of these, we're going to say that u is equal to x plus 1. We'll make that's going to be the u substitution. Therefore, du is equal to dx. Okay, so we've got u squared plus 4. And then the x is going to be u minus 1 du. Okay, and then u squared plus 4. Right? And now from here, we separate this into two separate integrals. U squared plus 4 and then we could take this 4 out. And there we go. So now each of these 4 we can solve. Okay, so here if we say that z is equal to u squared plus 4, then dz is equal to 2u du, so 1/2 dz is equal to u du. So we've got, bring out the 1/2 z and then dz. So we've got 1/2 natural log of the absolute value of z, 1/2 natural log of the absolute value of u squared plus 4, but u squared plus 4 is always positive. So we don't need the absolute value. Okay. So let me make some room here. Okay, so we've got 1/2 natural log of u squared plus 4. Okay, and then here we come back to this property. So this is going to be, with a is 2, we've got 1/2 arc tangent x over 2. Or no, u over 2. Okay, so minus 1/2 arctangent u over 2. And actually, were those the same? Let me see real quick. Yeah, so these are the same integral. So minus 1 plus 4 is just, you get minus 3 here, right? So this is 3/2 arctangent u over 2. That's what this is. So minus 3/2 arctangent u over 2. Okay. Now we just need to substitute this back in. So we've got 1/2 natural log of, now what is this x plus 1 squared plus 4? We can just go ahead and put this back, right? X squared plus 2x plus 5 minus 3/2 arc tangent, and then u is x plus 1, all right, plus c. Okay, and this in the answer key says that this should be a plus, so I missed this. I just forgot to apply a minus sign, or I applied a minus sign by accident somewhere. So, but this is the integral.